Remember, in this question paper, easily one can score 35 or 40 marks. Easily. I'll show you how. Now, see, question wise, you need to go. You have some wave function. They have defined the function over here. It is propagating in the positive x direction. T is the tension. M is the mass per unit length. See, you already know total energy per unit length. What is the total energy per unit length? This is simply T dou y by dou x square. If it is KRP, half of that. See, for this first half portion, second half portion slope is the same. So therefore, T into M square, remember this is per unit length, whether it is a left half or right half. So total energy of portion A, total length is A, is nothing but Tm square times A. That's it. So 3 marks you can comfortably score in this question. 3 marks. Next. A transverse wave is propagating in the positive x direction. T is equal to 2 seconds, x is equal to 4 mm, displacement is given as 2 mm. With the passage of the time, y coordinate increases and reaches to a maximum of 4 mm. See, practically speaking, what should be the wave equation form? First of all, filter the options. This is not going to be the wave. This is not going to be the wave because both are representing wave propagating in the negative x direction. Now you have two options. One option C, two option D. Now please try to please understand at t is equal to 0, x is equal to 4, it should be 2 mm. And it is positive. Means like, for example, if for example you are plotting the t is equal to 2 seconds, x is equal to, this is how the waveform should be. This is how the waveform should be. So therefore, among these two, what is correct? See, if I take let's say t is equal to 0, x is equal to 4, then option C is y is equal to 4 sine 5 pi by 6. That's a negative value. Sine 5 pi by 6. It is almost pi by 6 is a 30, right? Pi by 6 is 30. It is around 150 degrees. Means, see, these are two possibilities. This can be, this phase angle can be, this phase angle is pi by 6. Another possibility is function like this. And this is 5 pi by 6. Now, next instant, what is going to happen? As the wave move forward, what is going to happen? Please try to understand. You said the passage of time, its y coordinate increases. But if you see this as the criteria, if it is a y versus t graph, this is y versus t graph. Y versus t graph. With the time in the second is right. Next, consider a wave represented by equation y is equal to a cos square omega 2 minus kx. You can write a like a cos square phi as a into 1 plus cos 2 phi by 2. You can write it like this, which is y is equal to a by 2 plus a by 2 cos 2 phi. So in this case, you can write this as a by 2 plus a by 2 times cos 2 omega 2 minus 2kx. Clearly, this function amplitude is a by 2. This function frequency is 2 omega. Remember, what is 2k representing? 2 times 2 pi by lambda. So whatever the term is there, you can write this as 2 pi by lambda by 2. Kx. Kx place lambda is lambda by 2 here. So therefore, it's an amplitude a by 2, frequency 2 omega, wavelength lambda by 2. Now you see 1, 2, 3. Minimum 9 marks I got only from here. Only from here. First 3 questions. A plane progressive harmonic wave given by some equation so and so, fine. Unit cap, n cap is a unit vector in the direction of, okay, fine. General form is y naught times sin omega t minus k bar dot r bar plus some angle phi. That is how general form of a wave equation. So in the place of k bar, what you have is k bar, you have 3i cap minus 4j cap. A unit vector in that direction is 3 by 5 I cap minus 4 by 5 j cap. So therefore, from this 3 by 5, 4 by 5, only you have in this. Correct. But let me just check whether my V is correct or not. Magnitude of K is 5. Magnitude of omega is 2. You know velocity formula is omega by K. 2 by 5. That becomes 0.4. Answer is 0.4 meter per second. Even fourth question is also easy. If you know that is a form of representation, you can comfortably answer that. Right. Now you see 12 marks, anyone can score till this point of time. Next. Now see, these questions will definitely take time, and hardly it takes more than 4 or 5 minutes to just score 4 marks. So usually such models you postpone it for the later. Later, no issues. We will go with this. A metal sphere of radius A is surrounded by a concentric metallic sphere of inner radius B and outer radius, inner radius B, no, inner radius, concentric metallic sphere of inner radius A, outer radius B greater than A. There is some, okay, the space between the spheres is filled with a material whose electrical conductivity varies as sigma is equal to Ke, where K is a constant. A potential difference V is maintained between the plates. Fine. Now, see, try to please understand how to complete this particular question. Why? Because, see, normally I would have written V by R. Now, you take an elemental portion in this. This is an elemental portion whose radius is R. thickness dr. What is going to be the resistance of this portion? The resistance of this portion, normally I would have written it as the resistance of this portion, resistivity times dr by 4 pi r square. No one have given you resistivity, but conductivity is reciprocal of resistivity. Therefore, this can be written as 1 by Ke dr by 4 pi r square. So what we will write in general in this particular part is current at this point is dV by dr. So therefore, this is equal to dV by dr is equal to dV by dr is equal to, you just mark the conditions over here, dV by dr. dV means EDR and dr means just now we have written dr by Ke 4 pi r square. Cancel. So finally you got this one as E square K 4 pi r square. Exactly the same. So when A is correct, B is wrong. Right. Now you got everything very clear. Now what you want is, clearly I can write in terms of current. In terms of current, E I know basically. So dV is EDR. E is nothing but I by 4K pi times 1 by R dr. Do the integration for this from A to B. So what I am going to get in this is root I by 4 pi K log E B by A. Log E B by A. So 4 pi K I by 4 pi K log E B by A. So therefore, which is greater? I think they have given answer as C, but I got it as B. 1 by 2 pi log potential difference. This is wrong answer. This is the correct answer. It should be AD, not AC. They have given AC as answer. Right. Okay, bit difficult when compared to the questions which we have done till this point of time. Right. 31st question. Figure shows the net power dissipated in R versus the current in a simple circuit shown. Our maximum power theorem is what you need to remember. What is maximum power theorem suggesting us? When load resistance is same as internal resistance, power delivered is maximum. So therefore, P maximum is I square times R. So the maximum power given to me is 5. So 5 is equal to I square 25 times R. So internal resistance is 1 by 5 or 0.2 ohm. A is correct. Next, you want EMF of the battery also. No issues. At this point of time, current is 5. E is I into capital R plus small r. So I into 2 small r. We got I already. We already have 5 amps. 2 into 0.2, which means this is 2 volt. 2 volt. Correct. R at which power is 5 watt is 2.5 ohm. Wrong. At I is equal to 2 amp, power is. At I is equal to 2 amps. 2 amps. Power is. Earlier, you do you do whatever the question. Okay. You do whatever the question. Finally, you can answer that particular only from the graph. Irrespective whether you don't know A, B, at least you can answer D. But still, how to answer this, I will explain. We now know E is 2 volt, right? And internal resistance, we got it as a 0.2 ohm. Okay. When current is 2 ohm, when current is 2 ohm, 2 volt is equal to 2 by capital R plus 0.2. R plus 0.2 is 1 ohm. At that point, load resistance is 0.8 ohm. What is that they are asking? I square R. 4 times 0.8, 3.2 watt. Right. So this is a very clean hit question. But it is equivalent to more than 2 questions. So it will kill some time definitely. Next. Transverse wire are being produced at one end x is equal to 0 of a wire stretched along x-axis by a tuning fork of R. This is a direct question, formula-based question. Transverse waves are being produced at one end x is equal to 0 of a wire stretched along x-axis by a tuning fork along y-axis. The frequency of the fork is 400 Hz. Linear mass density is given. Hold on. You have given frequency, you have given mu. It is observed that at a certain moment of time, 2 consecutive particles at extremes are located at x is equal to 100 and x is equal to 200 centimeters. Right. See, what does this means? 2 consecutive particles located at extremes. People may misunderstand this. He is speaking about the distance between these 2 points, which is 100 centimeter. So therefore, you have wavelength, which is 2 times 100 centimeters, 2 meters. You already know frequency, 400 Hz. Velocity is frequency times lambda, 800 meter per second. Root T by mu is equal to 800. T is equal to mu times 16 into 8 is 64 into 10 power 4. Mu you have given 5 by 100 into 64 into 10 power 4. So solving which 564s, they were absolutely correct. Speed of the wave, 800 meters, absolutely correct. Wavelength of the wave, 2 meter, absolutely correct. At least these 3 you can answer. Whether you are comfortable with that or not, that's a different story. Maximum velocity of the particle of the wire is 85 meters per second. Very simple. What you have given to me is omega A. Omega A is given as 80 pi. Omega, hold on. What is omega? 2 pi by F. A is 80 pi. Pi cancel. The amplitude is 80 into F by 2, which is nothing but 40 times frequency, 400. So this is a 16K.
2 pi f kada sir.
2 pi F, right. 2 pi F. Thanks, Ra. 2 pi F. Omega A. 2 pi F. A is 80 pi. 2 pi F 400. A is 80 pi. Pi cancel. Okay, 42 times. Therefore, amplitude is 1 by 10 meter or 10 centimeter. Absolutely correct. This you can pack out. Multi-student osari. I don't know what best you can do in this. Leave it. No issues. I don't expect that you do this. But whereas you can comfortably do this. You can comfortably do this. Next. Which of the following actions would make a pulse travel faster? V is root T by mu. Root T by density times cross-sectional area. Yes. Right. Move your hand up and down more quickly as you generate pulse. It is independent of frequency. It depends on the inertia factor, tension factor of the wire. Using a heavier string of same length. No. Using heavier string means denominator is high, velocity becomes low. So it can't be, you want faster. This makes, this event makes the speed of the pulse slower. Use a lighter string of the same length and the same tension. Absolutely correct. Denominator is reduced, fraction increases, speed increases. Stretch the string tighter. Yeah, obviously. More is the tension, more is the speed in the string. At least this question you can answer. This is a original previous IIT question, actually. I don't know how many have done this. Original previous IIT question. Okay, but bit time taking, no issues. A mass M hangs vertically at the bottom end of a uniform rope of constant mass per unit length. The top end of the rope is attached to a fixed rigid support at O. A transverse wave pulse lambda naught is produced at O on the rope. The pulse take TO. See, remember, you should not consider the mass of the wire. If you are not considering the mass of the wire, tension is same throughout, mass per unit length is same throughout, so speed is same throughout. So therefore, obviously, what will happen? Bottom to top, whatever the time it takes, top to bottom also, it is the same time. So therefore, this is absolutely correct. Remember, this is correct only when the mass of the wire is negligible. So at any point of time, tension at any cross section is due to the weight suspended, not due to its own weight. So the wavelength of the pulse one becomes longer when it reaches point A. Wrong. Throughout speed is the same. Throughout wire is the same. So why frequency is the same? So how come lambda changes? No. The velocity of any pulse along the rope is independent of its frequency and wavelength. True. It depends on tension, mass per unit length. So C is absolutely correct. The velocity of the two pulses, 1 and 2, are same at the midpoint of the rope. Magnitude is same. Directions are different. Lot of students will mark ACD. They will go wrong. Velocity speeds of the pulses 1 and 2 are same at the midpoint of the rope is correct. This is wrong. Velocities, directions are opposite. At least this question and this question you can comfortably answer. The main problem is you are not working. That's the problem. So, this is the general form of a wave equation. Wave is propagating in the negative x direction. So, therefore, wrong. And it is in the form of x plus vt. So, v is equal to 3 meters per second. Correct. Amplitude of the wave. Maximum value of this function is 3. Correct. The pulse is symmetric pulse. True. It's a symmetric pulse. Think, it will be like this. It will be like this. Now, what happens? At t is equal to 0, suppose if this is the pulse, at some time t later, the pulse will shift leftwards. If there is a minus sign there, x minus 3t, then what would have happened is the pulse would have shifted rightwards. I think every teacher, S.C. Verma, solid example. You can do this one at least. Ikkade చూడండి, with these 3 questions, you are getting 12 marks. And with this, 16 marks. With this, 1, 2, 3, 4, 5. 20 marks only from this part. And 3 questions already I mentioned here. 3 nahi. I think I'm 4. 1, 2, 3, 4. 4. 12 plus 20. 32 marks you can score only from these questions. 9 questions. 32. Trust me. Why should you trust me? I proved already. A sinusoidal wave 5 mm in amplitude are to be transmitted along a string with a linear mass density equal to so and so. Source can deliver an average power of 90 watt. String is under tension 100 Newton. At what? I know only one thing. What is the formula for power? T times dou y by dou x times velocity of the particle, or velocity of the wave, actually. Velocity of the particle, sorry, not velocity of the wave. At that point. Okay, who cares for this? You need to use average power. What is average power formula? Average power formula is half T. ఇది గుర్తుపెట్టుకుంటే వచ్చేస్తుంది మీకు. Omega K. There are different ways you can represent this, not an issue at all. Whatever the data is given, accordingly you proceed. Half into tension given 100 Newton. Amplitude also given 5 mm in amplitude, 5 into 10 power minus 3 square. Right. Omega we need to find. Okay, 1 minute. Omega K you can modify. Omega by K is V. Where there is K, you can write omega by V. So therefore, this can be written as omega square by V. Okay. We want to find frequency part actually. Don't worry, V is root T by mu. Tension is 100 newtons. Mu is given as 4 into 10 power minus 2. This will become 100 by 2, 50 meter per second. Now you substitute all that over here. 90 is equal to 50 into 25 into 10 power minus 6 into omega square 4 pi square f square by 50. 50 cancel. Hold on. Pi square can be taken as 10 as informed, right? Now what will happen is 9 by 25 into 4 into 10 power plus 6 under root is frequency. This will become 3 into 10 to the power of 3 by 10. Actually, f by 100 is 3. I got to say, actually. The only thing is formula based. This formula, if you know, you are done. If you don't know this, you are out. Next, in the circuit shown, length of AB is 10 centimeters. Then find the value of L1 by 10 in centimeter, where L1 corresponds to null point. See, you know earlier, entire thing represent one single cell. One single cell. Or another way that I can manage is the drop across this is the same as the drop across these 2 points. If that is what you have, automatically you can get the required, you can represent the entire thing as 1 minute. The entire thing, E1 R2 plus E2 R1 by R1 plus R2. That is the effective EMF of the combination. So 100 times 28 plus 50 times 72 divided by 100. So this is 215 to 2. No, hold on. 100 kada. 28 plus 72 by 2. 36. So what is 28 plus 36? 64 volt. Right. That is a different. This is all Vs. What is the general formula? Potential gradient into balancing length. 64 is potential gradient means 1 minute. Total voltage is 100. Total resistance 150 plus 50, 200, 200 plus 800, 1000. That is the potential that actually I have run current actually. Current into L1 by total length 100. Right. One minute. Potential gradient across. 1 minute. Don't tell. I'll do it. Potential gradient across the potentiometer wire is the drop across this by the length of the wire. Actually, we have just mentioned current is 1/10. 1/10 into 800, 80 volts by resistance 100. Length of the wire 100. 80 by 100 into L. 8 is 64. So L by 10 is 8. I got the same. Only thing you need to remember the part. A easy question. Wow. A string of length L consists of two distinct sections. The left half is a linear mass density fine. Right half has only thing is L by V1 plus L by 2 by V1, L by 2 by V2. L by 2 common if I take mu1 by T plus mu2 by T. Right. So L by 2 times, in fact, mu naught by, what is the tension? Tension is F naught into, here it is 1 by 2 plus 3 mu naught by F naught. Boys, this is the relation. This can further be written as 2. Why I am doing this? Then what is happening is 1 plus root 6. So the answer is alpha plus beta, 7. Absolutely correct. Done. One step. This is crucial. If you know this, you are done. Now you tell me, I have started around 2:05 approx. Now the time is 2:38. In a matter of 33 minutes, mostly I have done the question paper. But still, we have some other questions left. All these I have done. Only 6 questions left. Right. We'll work on that right now. I think I have done all except these truncated passages. You know why I have left intentionally? Because hardly I'll get 12 marks, maybe, but they will kill a lot of time. In the figure, PQ is aware of uniform cross section and of resistance or not. A is an ideal ammeter, and the cells are of negligible resistance. A jockey J can freely slide over the wire PQ, and contact on it is at S. The length of the wire PS is 1 by nth of PQ. Then answer the following, given F is equal to 1 by N. Right. Now the question is, how to handle this particular part. Hold on. Forget about ammeter for a while. Or, and this resistance is R1. And this resistance is R2. Remember, here it is P, here it is S, and here it is Q. Right. Now, automatically, EMFs are same. Right. Okay. So, frankly speaking, in this, what is that you want? If there is any current, it has to pass through R only. Right. Okay, no issues. So what is I1? According to me, I1 is E by current. According to me is, if I take the left hand side loop, for example, minus E, I1 plus I2 or plus IR1 is equal to 0. For this, minus E I1 plus I2R plus IR2, I1, I2 is equal to 0. So you want the case for maximum and minimum value. Very simple. If the potential drop across these two is the same, that is the minimum value. Or least otherwise. Let us work in this particular way. Why they have introduced F? The length of the wire PS is 1 by nth of PQ. Given F is equal to 1 by N. Okay, F parts means PS is F times PQ in terms of resistance. Okay, right. No issues. So we assume the left side part as R1. So according to me, R1 is F times R0 and R2 is 1 minus F times R0. Fraction law తీసుకుంటే R1 plus R2 తీసుకోండి, you will get R0. So now you take the first loop, the same loop, same loop. If I take the first loop, if I substitute this particular data, we will call I1 plus I2 as I. So minus E plus IR plus I1 times R1 FR0 is equal to 0. So therefore, I can write I1 as E I1 or I1 as E minus I1F R0. Similarly, you can write the same equation as IR plus I2 times 1 minus FR0. You'll get 1 minute. 1 minute. IR. IR as E minus. Now you will get I1 and I2 values. I1 and I2 values from these two. So you can write I1 as E minus IR by FR0. You can write I2 as E minus IR by 1 minus FR0. The sum is again I. So I is E minus IR times, in fact, R0 is also common, 1 by F minus 1 minus F. You need to solve this. But by solving, you will get I value as E by R plus R0 times F minus F square. Now remember, if this is 0, I is maximum. Means if F becomes F, I think R0 times F minus F square, అది F is equal to F minus F square 0 కావాలి, F1 కావాలి, F1 కావాలి. అలా అయితే మ్యాక్సిమం అవుతుంది. మినిమం అంటే ఏమవ్వాలి? మినిమం అయితే ఏం కావాలి? F is a variable quantity here. Now very simple, I got the point. Do di by df here, that's all. You will get two values. That is the reason why I am doing this problem last. You will get two different values. If it is multi-correct answer type, we can try. But it is a numerical type. You should do till the last. Like the question, undoubtedly. Mathematics is more dominating. Physics is easy in this. Next. One end of a 60-meter long rope of mass M is equal to 1.8 kg is tied to a rigid horizontal support held high above the ground. The rope hangs vertically and keeps taut by a weight W. suspended lower. A person jerks the lower end of the rope. But what is the difference between the previous multi-correct answer type and this question? This is a massive rope. So tension is not same at every point. A person jerks the lower end. No, suppose you are taking this distance as y, for example. So at this point, tension is nothing but W plus weight W plus 1.8 by 1 end of a rope, 60 meters. Why? For a while, you will write it as a lambda because unnecessary repetition will happen. Or mu, because lambda wavelength kuda అయిపోతుంది మళ్ళీ. Mu stands for mass per unit length. Mu yg. Hold on. That is the tension at that point. What is that you are saying? A person jerks the lower end of the rope sideways in a sinusoidal manner and a transverse way of this frequency, and this amplitude passes over along the rope, so that there are 2 cycles of wave in the total length of the rope. Right. Neglect the weight of the rope as compared to the suspended weight W. Thank God. Neglecting the weight of the rope as compared to the suspended weight W. So therefore, this is a small. This is a small when compared to. So therefore, T you can take it as a W. Tension you can take it as W. You said 2 cycles in the full length, which means 2 lambda is the length of the wire. Length of the wire is a 2 lambda. So lambda is nothing but hold on. Lambda is nothing but L by 2, which is 30 meters. And the frequency is 2 hertz. So velocity of the wave is 30 into 2, 60. Hold on. Root mu g is 60. Did they mention the W? No. So you want W by mu g is 60 into 60. Hold on. Okay. Mu into 60 is W by mu g, na mu only, please. Right. So mu into 60 is W by 60. Arayar, what is this? Mass of wire. You know what is this? Mass per Arayar, please see that. What I have written here? W by mu, almost we got W by 60. W, weight W. I'm not confusing you. I'm just giving an idea. Just please follow. This is length L. This is numerically equal to L. Hold on. Now you square on both the sides. W by mu is L square. So mu L mass is W by L. So mass of the suspended wire is mass of the suspended wire W is mu L square. Mu L square. They're asking W in fact. Hold on. W is equal to mu, I know. 1.8 by 60 into 60 into 60. 60 cancel. 1.8 into 60. 18 into 6. 60 plus 48. 108 Newton. But in kg, kg weight, it is a 10.8. Because you asked mass, not weight. Lot of students will go wrong in writing it as 108. Next. Maximum rate at which energy is transferred to the power wire. You know what is that they're asking? They're asking about power. Instantaneous power. Just now I have given the relation. What is that? t into dou y by dou x into velocity of the particle. So if you write everything properly, dy by dx is ak, maximum value. Maximum value is omega a. This you need to modify. Okay, velocity of the wave, the substitute here, that's all. Just a substitute, you got every value here available. They have given amplitude also. See, amplitude also they have given. K, 2 pi by lambda. Omega, we already have frequency, 2h. Tension, just now we have identified 108 newtons. Amplitude, 1 by 10. K, 2 pi by lambda. Lambda is 30 meters. Omega, 2 pi f. 2 pi f. F is 2 heads. And again you got amplitude, 1 by 10. Now you substitute all, you will get the answer. But see, remember, the major logic here is calculation. People will lose marks in calculation. Take care of that. One last question. Sinusoidal wave is propagating in the negative x direction in a string stretched along x-axis. Particle of the string x is equal to 2 meters is found at its mean position. Mean means normal position. And it is moving positively in y direction at t is equal to 1 second. Right. The amplitude of the wave, the wavelength, and the angular frequency, lambda is given meter. Wavelength, the amplitude of the wave is 0.1 meter. Wavelength is pi by 4 meter. Angular frequency, omega is given as 4 pi radian per second. Right. Right. At x is equal to 2, it is found at its mean position. Remember, x is equal to t meters, dou y by dou x is equal to 0. Because you said at its mean position, not extreme position. Mean position, slope is 0. So instantaneous power transferred is 0. It is that I can answer immediately. Next, speed of the particle at x is equal to 2 meter and t is equal to 1 second is. Now it is a different time. Please remember, it is at a different time. Arya, please try to understand what is the time period here. 2 pi by omega. 2 pi by 4 pi means the time period is 1 by 2. Time period is 1 by 2, boys and girls. And you asked 1 second. Means again it is at the mean position. Total time period is a half second. You are asking at 1 second. What is repeated at t is equal to 0 gets repeated at half second and gets repeated at 1 second. So obviously what is going to happen is this particle is now again the same direction velocity. What is that velocity? Omega a, maximum velocity. So this one will have omega a 4 pi times amplitude. Amplitude is 1 by 10. So what I am getting is 4 into 3.14 by 10. 4 into 0.314. 4 4 is 16, 4 1 is 4 5, 4 3 is 12. So it should be 1.256. They may give you range as 1.25 or 1.26. Better you go for 1.26. Right. That's all. I've done the question paper. Every question I have done, please remember. Suppose if I'm an average student, in my prospectus, I can do this question. Okay, leave this. I can at least do this question. Leave this. Leave this. Leave this. Leave this. One at least I can do. 2 marks I can score in this. Leave this. I can do this. I can definitely do this. Definitely I can do this. Definitely I can do this. Definitely I can do this. Okay, I don't know. I'm not sure whether I remember formula or not. Even this also I'm not sure. This I can do it. Now you please count my marks. I'm an average student. 4, 4, 4, 12, 12 plus 4, 16, 16 plus 4, 20, 20 plus 4, 24, 24 plus 2, 26, 26 plus 3, 29, 32. 28 marks minimum you can score. That's the problem with you. You are not scoring that. Any teacher who teaches element